So for this video, we're going to be looking at number properties. This is video 1.3. This is sort of some general knowledge, general ideas about numbers, and this stuff isn't necessarily, like, you will be examined on this, but these number properties is something that will underpin all the maths that you do kind of forever, okay? So these things are basics that I really want to help you get right so you never have to worry about it again. So actually, the properties of numbers is a fascinating topic. I want you to think about the number 1 for a moment. Some of you might think, well, it's a bit boring, but in fact, the number 1 is a really exciting number because it's this thing called, well, one of its properties is that it is the multiplicative identity, which means that 2 times 1 is 2. 7 times 1 is 7. 1001 times 1 is 1001, which means no matter what you multiply by 1, you end up with what you started with, which is actually quite interesting, which as well means that 1 is its own square. So 1 squared is equal to 1. The square root of 1 is equal to 1. So that's just quite interesting. You don't get that with any other number. So 1 is actually quite important, and looking at these properties of other numbers just brings out these excellent, amazing patterns, and that's some stuff that we'll get to have a chance to have a look at this term. So there are some very important properties of numbers that we're going to talk about, and the first is multiples. Okay, so to get a multiple of a number, you multiply that number by the set of counting numbers. So the set of counting numbers are numbers like 1, 2, 3, 4, etc. Okay, so that means that if we had the multiples of 4, you would have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, etc. Okay, you just keep going and going and going with multiples. As long as there's integers, counting numbers to go, then you can create multiples. However, sometimes you ask for the lowest common multiple, which is the smallest multiple from a set of numbers that is common to them all. So let's say we wanted the lowest common multiple of 3 and 8. Okay, so I'll show you how I set it up, and I'd say that this is probably not a bad idea for you. So let's do it in columns, eh? So we've got 3 and 8, and multiplying by 1, by 2, by 3, by 4, by 5. So 3 times 1 is 3, 3 times 2 is 6, 9, 12, 15, 18, 21, 24, and I'm only going that far because you'll see why in a sec. 1 times 8 is 8, times 2 is 16, times 3 is 24. So as soon as you hit with somewhere having the same number, you could keep listing these on, like 24, 4 8's 32, 40, etc. And you'd find other multiples maybe, but we're only looking for the lowest, okay? So as soon as you run across the numbers that are the same, bang, you're done. So the lowest common multiple of 3 and 8 is 24. Okay, so that's how you do lowest common multiples. Right, a factor is an integer, which is a whole number. So please, I will actually use the word integer in class. So please be aware of what it means. It means whole numbers, so all the way in the negatives and the positive zeros included, that divides another number with a remainder of 0. Okay, so for instance, a factor of 12 is things like 3, because 12 divided by 3 is 4. Remainder 0. Also, we've got 4. Also, 12 is a factor of 12. 1 is a factor of 12. 2 is a factor of 12, and 6 is a factor of 12. Okay. Now you'll realize soon that factors usually come in pairs. Okay, because it's two numbers need to be multiplied together to get that number you're trying to find. Now, there's another thing we can do. Sometimes you want to investigate what the highest common factor between a set of numbers is, okay? Which ends up being the largest factor from a set of numbers that is common to them all. So I'll set this up like before. We might go the highest common factor of 24 and 30, okay? Right, set it up in columns like before. We're looking for highest common factors, 24 and 30. Now, you list off all your factors. So 24, we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, and I think we've exhausted them all. 30, 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, 7, we've done. Okay, so now we have a look. Okay, well 1's not the highest, 24 doesn't get shared, 2 does get shared. Okay, 2 gets shared, 3 gets shared, 4 doesn't, but 6 does. So out of 2, 3, and 6, which is the highest? Well, 1, 2, 3, and 6, which is the highest? It happens to be 6. So it means the highest common factor of 24 and 30 is 6. Okay, so that's how I'd like you to set out your highest common factors, because I think that it's easier this way. Later on down the track, maybe you'd be able to see them straight off your head, which is great, and it will really help you with factorizing stuff in algebra. So I want you to very much concentrate on becoming quite proficient at finding highest common factors. Right, prime numbers, they only have 2 factors, 1 and itself. Okay, so that includes numbers like 2 and 3 and 5 and 7 and 11 and 13 and 17 and 23. And you think of numbers that don't have any other factors, okay? There's nothing else other than 1 and 13 that you can multiply together as an integer to get 13. Okay, it's only 1 times 13. Same with 7. Only 1 times 7 will work. Same with 17. Only 1 times 17. Okay, so that's how we get these prime numbers, and we will do an activity in class to sort of investigate those. Right, composite numbers. They have more than 2 factors. Okay, so anything except for 2 that's an even number. So 4 is a composite number. 6, 8, 12. We can grab out 15 as a composite number because we have 1 times 15 and 3 times 5. Okay, 12 is 1 times 12, 2 times 6, 3 times 4. See, all of these ones, 1 times 8 and 2 times 4, all have more than 2 factors. Okay, so 2 and 4 are factors of 8, therefore it's a composite number. 3 and 4 are factors of 12, therefore it's a composite number. Okay. Right, the square of a number. So, the square of a number is where you raise a number to the power of 2. So, if we have 3 squared, right, the way I want you to say this is 3 squared, or 3 to the power of 2, or 3 to the 2, not 3 2, okay? There's a lot going on with that. I've seen a lot of mistakes happen, but remember that this means it's the same thing as the bottom factor multiplied by itself this many times. So 3 times 3. Okay, so the 3 comes from this thing here, and the fact that there are 2 of them comes from this one here. Now you might be thinking, duh, but so many problems with this one. So 3 times 3 is 9. Okay, now you do have a little squared button on the top of your calculator, but I do want you to know what this means, because you might see later on x squared, because you need to know that's the same as x times x. Okay, just remember that 3 to the power of 2 or 3 squared doesn't mean 3 times 2. I'll probably cry deeply if I see you do that. Okay, right, square root of a number. what we're asking when we're asking what the square root is what number, a, which is what we're trying to find out, when multiplied by itself, gives us this number b. Okay? So, if I have the square root of b would equal a. What number, a, when multiplied by itself, gives us b? Okay? So, you would have a reciprocal of this question is sort of like a squared equals b. Okay? So when we're looking at this square root, some of the ones you should be familiar with is things like, what's the square root of 16? Well, you think, what number multiplied by itself gives me 16? Well, if you know your times tables or your perfect squares well enough, you should know that it's 4. Or, what's the square root of 49? You should know that that is 7. Okay, because you should know your perfect squares. You should know your times tables well enough to be able to crank this stuff out on the spot. Okay, you do have an operation on that with your calculator, but it is something that you do need to be able to know for some sets of numbers to be able to do it off your head. Okay, so that's all we have for this video today. So have a look at that, have a look in the textbook, and become familiar with some of these number properties because we will be using them a lot later on down the track. Okay, thanks for watching.